Hello everyone. In this video I'm going to solve this exercise covering monopoly and perfect competition. The problem starts in monopoly and then moves into the long run equilibrium in a perfectly competitive market. As always, I recommend you attempt the problem and then come back to watch the solution. The information we are given is the demand function and the cost function. In part A, we are going to figure out the profit maximizing price and quantity for a monopoly. First thing we always do for a monopoly problem is to find the inverse demand function by solving the demand function for P instead of Q. So I'm going to add P to both sides and subtract Q from both sides to get P of Q equals 120 minus Q. From here I'm going to set up the profit function for the monopoly, which is revenue minus cost. Revenue is price given by our inverse demand function times quantity minus the total cost of 25 plus Q squared. I'm going to multiply things out to clean this up a little bit. That's going to give us 120Q minus Q squared minus 25 minus Q squared. Collecting terms, I'm going to get 120Q minus 2Q squared minus 25. Next, we take the first order condition. So I'm going to take the derivative of the profit function, which is 120 minus 4Q. The 25 is just going to drop out because that's a constant, equals 0. Add 4Q to both sides is going to give me 4Q equals 120, and then divide both sides by 4 to get QM equals 30. To determine the monopoly price, we plug the quantity of 30 into our inverse demand function. So we're going to get 120 minus 30 equals 90. To calculate the profit that the monopoly makes, we'll take the total revenue, which is price times quantity, 90 times 30, minus the total cost, which is 25 plus Q squared. So we're going to take 25 plus 30 squared. This will be 2,700 minus 25 minus 900. That comes out to 1,775. For part B, we need to figure out the deadweight loss due to our monopoly, and the best way to do this is to draw the graph. Recall our inverse demand function is P of Q equals 120 minus Q. I draw that in something like that. Both intercepts here are going to be 120. For the marginal revenue, we just take our inverse demand and we double the slope. That's going to have an intercept down here of 60. The cost function in this problem is 25 plus Q squared, and so our marginal cost function will be the derivative of that, which is 2Q. When Q is 0, marginal cost is 0, so that's going to have a starting point right here at the origin. We know that our profit maximizing quantity is 30, which is going to be right here. And so our marginal cost curve will cross marginal revenue at 30. The deadweight loss will be the area that is lost due to our monopoly's reduction of quantity below the socially efficient point. To figure that out, we're going to set our marginal cost equal to our inverse demand. So we're going to get 120 minus Q equals 2Q. Add Q to both sides and we get 120 equals 3Q. And so our socially efficient quantity is 40. We know that our price is 90. And the only thing that's left to find is this point right here, because our deadweight loss is this triangle. That point is the value of the marginal revenue or the marginal cost, both are the same, at the quantity of 30, which is our profit maximizing quantity. So I'm just going to take our quantity of 30 and plug that into the marginal cost. So MC of 30, it's 2Q, so we're going to get 60. To calculate the deadweight loss, we have a base of 90 minus 60 and a height of 40 minus 30. Divide that by 2, we get 30 times 10 over 2, which is 150. For C, we are told that the barriers to entry have disappeared, and that is going to allow new firms to enter the market, which is going to create a perfectly competitive environment. We need to find the long-run equilibrium. In the long-run equilibrium in perfect competition, the price equals the minimum of the average total cost. So finding the minimum of the average total cost is our first task. I'm going to use small q to denote the output of a single firm in the market. So our cost function will be C of q equals 25 plus q squared. We know from before the marginal cost is 2q, but now we need to know the average total cost by dividing the cost function by q. So we're going to get 25 over q plus q. The long-run equilibrium happens at the quantity where average total cost equals marginal cost. So we're going to take 25 over q plus q equals 2q. Subtract q from both sides is going to give us 25 over q equals q. Multiply both sides by q to get 25 equals q squared, and then take the square root of both sides to get q equals 5. This is going to be our long-run quantity per firm. We can plug that into either the marginal cost or the average total cost to get our long-run equilibrium price. So PLR equals, using the marginal cost of 2q, is going to be 2 times 5, which is 10. To figure out the long-run equilibrium quantity in the entire market, we're going to take that 10 and we're going to plug it into our demand function, which, remembering all the way back to the beginning of the problem, is 120 minus P. Plugging that 10 right in there, we're going to get Q LR equals 120 minus 10, which is 110. And our final task is to find the number of firms in the market. For this, we will note that since all the firms are the same, big Q equals N times little q. So 110 equals N times 5. Dividing both sides by 5, we have long run number of firms 110 over 5, which is 22. And that's all there is to it. If you have any questions, feel free to let me know. Thanks for watching.